We're looking at pages 17 and 18, where we are factoring out a monomial GCF. So remember that a GCF means that we have a greatest common factor. And so we're looking for the GCF of polynomials, and it will end up being a monomial. So we're factoring one item out from every term. We're going to start by kind of reminding ourselves about prime factorization. So remember that prime numbers are numbers that factors are 1 in itself. So the first prime number is 2, and then we have 3, 5, 7, 11, 13, and so on. So when I'm creating a prime factorization of something, I want to think about the factor trees and factor by prime numbers. So I'm thinking about what prime numbers go into 12. So 12 is divisible by 2, and so that's a prime number. So I know that I can't factor it. I'm going to circle it. It's 2 times 6. 6 is not prime, so I can factor 6 as 2 times 3. So that would be the prime factorization of the number 12. So the prime factorization of 12 is 2 times 2 times 3. If I look at the next number 8 and think about it in the same way, 2 also goes into 8. So when I'm thinking about a prime factorization, I want to start with 2 and kind of make my way down with the prime values. So then 4 is not prime, but its factors are 2 and 2. And so the prime factorization of 8 then is 2 times 2 times 2. The last number we're going to look at is 6, because that's our coefficient here. So 6 is 2 times 3. Okay, so the prime factorization of 6 is 2 times 3. So if I'm looking for the prime factorization of each of these values within the coefficients of the polynomial, 12x to the 5th plus 8x to the 4th minus 6x cubed, I can see that 12 is 2 times 2 times 3, 8 is 2 times 2 times 2, and then 6 is 2 times 3. So if I want to find the GCF, it's what factors do they have in common. So notice that they all have this first 2. After that, though, 6 doesn't have another 2, so I can't say that 2 is part of the GCF, 3 is another 2 is part of the GCF. I also can't say 3 is part of the GCF because 3 doesn't go into 8. So as I'm identifying the greatest common factor, I can see that it's going to be 2 at least for this, because 2 goes into all 3 coefficients, 12, 8, negative 6. Okay, so then we want to think about the prime factorization of the variables. So when I'm doing this, I'm thinking about x to the 5th means that I literally have 5 x's. X to the 4th means that I have 4 x's. X to the 3rd means that I have 3 x's. So if I'm thinking about that in the same way, what do they have in common? They have 1, 2, 3 x's in common, and then I have no more x's in x cubed, so that means that my GCF would end up being 2x cubed because I have 3 x's there. Okay, so that's the idea of prime factorization. What we're going to use to factor is the hockey stick method. So when I factored this, I found the GCF is 2x minus 3 with each term. We're going to use the hockey stick method because it kind of shows us the factorization. So we're going to look at factored form within this lesson. So the hockey stick method is where I'm going to write out my polynomial. So my polynomial was 12x to the 5th plus 8x to the 4th minus 6x cubed. And I'm going to draw kind of an upside down division algorithm sign that looks sort of like a hockey stick. The hockey stick's more describing what happens outside. So as I do that, what I'm going to do is take my factors and think about it in pieces. So I'm going to start by looking at my coefficients. So looking at my 12, my 8, and my 6. So technically we just did this. I'm looking at what number goes into all three of those. Typically, I want to find the prime number just to make sure I don't miss anything. I can always start there to do it systematically. And so we already know from the previous portion that 2 goes into both 12, 8, and -6 because they're all even numbers. And so remember that I then want to write underneath here what I get if I factor out a 2. So remember that factoring is dividing, but it's dividing evenly. So 2 should go into 12 evenly. 12 divided by 2 is 6, and I'm just going to bring down the x to the 5th. 8 divided by 2 is 4, and I'm just going to bring down the x to the 4th. And then -6 divided by 2 is -3, and then I'm just going to bring down the x cubed. Okay, so I'm rewriting my polynomial, dividing my coefficients by the factor. So I divided, this is my monster spot. Okay, I divided my coefficients by the 2 that I got from here. So whatever my number is there, I'm going to divide my coefficients from that number. Okay, now I'm going to repeat this, but now I'm going to look at the variables. So as I look at the variables, I want to think about what is the GCF in terms of that variable. And what makes this nice is that I can actually just look at the last value when it's written in standard form. Whatever the lowest power is on x, that's going to be the common factor. So that means that I can factor out an x cubed because it's the lowest exponent on all of my terms. Remember that when I do this, because I'm dividing, oops, sorry, I need to write over there. Because I'm dividing by that x cubed, I'm going to subtract my exponent. So I'm going to subtract a 3 from each of these exponents. So I still have a 6, but now it's going to become x to the, I'm going to subtract 3, so x squared. And then plus 4x, I'm going to do 4 minus 3, so it's going to stay in x. And then minus 3, when I subtract 3 from 3, that becomes a 0, so there's no variable there. Okay, so whatever I end up with here, that's always going to be the variable with the lowest exponent in the expression. Okay, in that given expression. Okay, so the way that this works is that this product is my GCF. So 2x to the 3rd power is the GCF of 12x to the 5th plus 8x to the 4th minus 6x cubed. Okay, so we will use the hockey stick method to factor GCFs rather than going through the process of finding the prime factorization. Okay, so let's look at the next example. So in this example, they want us to factor, which means that they want us to write our answers in what's called factored form. So factored form is when I have my result in parentheses. Okay, so factored form is when my result is in parentheses. One thing that we want to make sure when we're doing any kind of problem is that this should be in standard form before we start. Okay, so we always want to think, okay, is this written in standard form? If it isn't, we need to. Ours is not, so I'm going to rewrite it underneath with the highest power first. So 36x cubed plus 16x squared plus 4x. Okay, and I'm going to draw the hockey stick. And I'm going to start with the coefficients. So I'm looking at my coefficients. And a good strategy to use is to look at what the smallest coefficient is and see if I can divide that number into each of the larger coefficients. So if I look at this, I have a 4 as my smallest coefficient on the last term. And I can divide 16 by 4. I'll get 4. If I divide 36 by 4, I'll get 9. So because that 4 goes in evenly, I can use the 4 as my greatest common factor, right? So I'm analyzing these numbers. A good strategy is to take the lowest one, and if it goes in evenly to the other two, then I can use it. If it doesn't, then I would have to go back to prime numbers and kind of start with 2 and see if 2 goes in, and then 3 and 5 and so on. Okay, so since this works, I'm going to divide everything by 4. So I already did my coefficients. I need to bring down the variables. So I have 9x cubed plus 16 divided by 4 is 4x squared. And then 4x divided by 4 is just x because 4 divided by 4 is 1. Okay, so then remember that when we do this next step, what we're looking at is our variable, and we're looking for the variable with the lowest power. So the lowest power we have on this expression is just a plain x to the first power. So x to the first power is what we're going to divide by to find our GCF in factored form. So if I divide by x, remember it has an imaginary 1, so that means I'm subtracting 1 from 3, I'm subtracting 1 from 2, I'm subtracting 1 from 1. So I get 9x squared plus 4x to the first, so I'm not going to write it. And then for this one, this is where it could get tricky. Remember that x to the 1 minus 1 power is x to the 0. What does it mean when we have x to the 0? Because we're dividing, it means that we have a plus 1 there. Okay. So remember that what we learned is that this is my GCF. So 4x is the GCF of 4x plus 36x cubed plus 16x squared. Okay. So then the factored form is the 4x times the other trinomial. So 4x times 9x squared plus 4x plus 1 is what we call the factored form. Okay, so let me write that in green because that's what I wrote here. So this here is our factored form. Okay, so if it's asking me to write factored form, that means that that is my answer. Okay, so this is my answer for factored form of the polynomial that we were given. So then each piece is called a factor, right? So this would be our monomial factor because it's only one term. And then this other one is our trinomial factor. So when we are factoring with GCF, we should always have a monomial factor and then another factor that's the same amount of terms as our original problem, okay, in order to create another, in this case, trinomial. Let's look at another example. So for this next example, notice that we have a leading coefficient that is negative. So if I look at my coefficients, I have negative 24, positive 36, negative 54. This is in standard form. My leading coefficient is negative. So when that happens, I have to factor out a negative GCF. Okay, so I want my GCF to be negative, not the trinomial that's going to end up in the parentheses. Okay, so let's rewrite our expression with the hockey stick. So we've got negative 24x squared to the fourth plus 36x cubed minus 54x squared. Okay. So I already know that I have to take out a negative, right? I told you we have to take out a negative. And so that's because this guy is negative. So whenever that is negative, I have to take out a negative for my leading coefficient. Okay, I'm going to use a highlighter that's pink, so I'm going to change that back to gray. Okay, so I have to take out that negative. Then I'm going to follow the process exactly like we did before. So I've got 24, 36, 54. So remember our strategy last time was checking the smallest number and seeing if it goes into the others. 24 does not go into 36, so I can stop there. And so I want to try to figure out a number that goes into all three of these. Let's do the prime factorization method just for practice, meaning I'm going to start with 2 and determine if 2 goes into each of these. So if I think about that, 2 is even, and 24, 36, and 54 are all even numbers. And so I know that 2 is going to go into all of those. So let's divide everything by 2. So if I divide these by 2, I'm dividing by a negative, so I get positive 12 x to the 4th. And then 36 divided by negative 2 gives me negative 18 x cubed. And then negative 54 divided by a negative 2 is going to give me positive 27x squared. Okay, just to remind yourselves, as we did this, we divided by negative 2 that time. Okay, so I want to now check, do I still have something that I can divide out? Okay, so 12, 18, and 27, I want to figure out what other number goes into them. I cannot use 2 because of that 27. So I can see then that 3 will go into 12, 18, and 27. That's my next prime number. So I'm going to use that 3. Okay, so 3 does go into 12, 18, and 27. This is positive now, so I'm only going to have that one negative from the beginning. Okay, so 12 divided by 3 is 4. I'm still going to have that x to the 4th. We haven't done that yet. And then minus 18 divided by 3 is 6. We have x cubed. 27 divided by 3 is 9, and that term is x squared. Okay, so our last step here is to take the variables. So remember that we are going to take the lowest power. So in this case, our lowest power is x squared. So that's going to be part of our GCF. So we're going to divide out x squared. And then this time we are left with, we're going to subtract 2 from each exponent. So 4x squared minus 6x. 3 minus 2 is 1, so we're going to leave it. And then plus, remember when we do this, it's going to go away, right? Our x turns into a 1, so plus 9. Okay, so in this one, we're subtracting 2 from each exponent. And again, we're only subtracting 2 because that was a 2, right? That's where that 2 is coming from. Okay, so remember that what we learned is that this is our GCF. So our GCF is negative. If I multiply, 2 times 3 is 6. So negative 6x squared. So I multiply together to get my GCF. And so remember that is my monomial factor. So my monomial factor is negative 6x squared. I was given a trinomial, so I should have a trinomial factor left over of 4x squared minus 6x plus 9. So remember that this here is my factored form of that trinomial. Okay, so this page has a reminder that just reminds you that factoring is the reverse of multiplying. So remember that factoring is a form of dividing where my divisor goes in evenly. So I end up with 2 factors because there is no remainder. So we've been using the hockey stick method to factor. We've had trinomials. This is only a binomial, but it works similarly. So we have 3x squared minus 4y squared. And so when we're looking at our coefficients, we're looking for their greatest common factor. So 3 is a prime number. Its only factors are 1 and 3. 4 is composite, but its factors are 2 and 2, right? So that I can get 2 and 2 or 1 and 4. So notice that they don't have any factors in common. When that happens, I'm going to use a 1 to show that their only common factor with their coefficients is a 1. And so then if I divide everything by 1, I get still 3x squared minus 4y squared. What ends up happening now is that when I look at my variables, they're different. So I don't have an x that I can factor out of both terms. I don't have a y that I can factor out of both terms. So what that means is that 1 is their only factor. So remember that the definition of prime is that something's factors are only 1 and itself. Okay, so sorry, that's an ugly prime. So a polynomial can also be prime. And as long as its factors are only 1 and itself. So this polynomial is what we call prime. Sometimes they might call them not factorable, so you might see that as something in other in worksheets or in with other materials, but it's not factorable if its only factors are 1 in itself. So think about it like a prime number, right? 3's only factors are 1 and 3. So 3 is a prime number versus 4 is not a prime number because it has a factor of 2 and 2, right? So that one's not prime, but they're relatively prime. They don't have common factors. Okay, so let's look at the next one on that page before we move on to page 18. So if I have this one, they want me to factor 5 minus 16x squared. So remember that our first rule is that we need to have this in standard form, and that's not. So we need to change it to negative 16x squared plus 5. Okay, so if we want to factor that, what's our rule about leading coefficients? So our rule is that if the leading coefficient is negative, then we have to factor out that negative, right? So I have to take out a negative number. As I'm looking at my coefficients, I have 16 and 5. 5's prime, and it doesn't go into 16, so that means that they don't have anything in common. So that means that negative 1 would be my greatest common factor. So I can factor that out to be, if I divide by negative 1, 16x squared minus 5. Okay, so don't let this one trick you. Negative 1 is the GCF. So negative 1 is the GCF of negative 16x squared plus 5. It factors to be negative 1 times that 16x squared minus 5. Remember that I don't have to write that 1, so I could leave it as just negative in front, right? Because that negative 1 is the factor. So my factored form would be negative, and then the quantity 16x squared minus 5 as my factored form. Okay, let's look at page 18 and practice a little bit more. So these look more complicated, and they might look like they aren't factorable. So we're building towards what we're going to be doing later on when we're factoring by grouping. So you'll get used to the way that this looks. So I am going to factor this. It is not prime. So I'm going to rewrite my 5x times x minus 7, and then plus 4 times x minus 7. So remember that factors are things that are being multiplied together. So when I have something that looks like this, and they have something that is multiplied like that in parentheses, that is a common factor. So that means that both terms here have an x minus 7 that I can factor out. Remember, if I'm dividing to simplify, if I divide by x minus 7, I'm dividing by something that will reduce away. So 5x times x minus 7, if I reduce by x minus 7, I'm left with 5x. 4 times x minus 7, if I divide by x minus 7, I'm left with the 4. So I can factor out that binomial. That's my common binomial factor. because it was part of both terms. And I'm left with the result of 5x plus 4. 5 and 4 have no common factors, and I don't have an x term with the 4. So that means that that is my resulting other binomial factor. So that means that I can write this in factored form as x minus 7 times 5x plus 4. So that would be factored form of 5x times x minus 7 plus 4 times x minus 7. Okay, so let's look at one more that looks very similar, and then we'll change it up a little bit. So for the next example, we have a similar expression. We have 3x times a binomial x plus 5 minus just the binomial x plus 5. So I'm going to remind you of something. If I do not have a coefficient, remember that there's an imaginary 1. Okay, so this will be helpful when we are simplifying. So if I look then, what is my common binomial factor? X minus 5 is part of both terms, so that means that I'm going to use x minus 5 as my common binomial factor. When I divide by x minus 5, my coefficients are the only thing that's left. So I'm left with a 3x. Notice that if I didn't put the 1, I might get confused and think that it drops, but I won't have a binomial. I have to have a binomial because I have two terms here. So when I divide this one by x plus 5, I'm left with negative 1. So my common binomial factor is x minus 5, and then my resulting binomial factor is 3x minus 1. So factored form of this expression is x minus 5 times 3x minus 1. Okay, so these are going to look a lot more complicated, but we're going to follow the same strategy. So for this one, I don't have parentheses in the first terms. I have 1, 2, 3 terms, and I only have this x squared plus y squared there. But notice that that is what I have over here. So I have an x squared plus y squared, and I have an x squared plus y squared. So let's structure this first part to look like how it looked here, right? I had just parentheses around it. I'm going to put parentheses around that one. So let's write that in a hockey stick with those parentheses. So I'm going to put parentheses around my x squared plus y squared. What should I put in front then? I should put a 1. And then I have plus 9x times another quantity of x squared plus y squared. Okay, so now I can see that common binomial factor a little bit better because it's separated by those parentheses. So I can factor out the x squared plus y squared. And remember that as I'm factoring out, I'm dividing by that. So when I divide something by itself, I end up with 1. And then when I divide here, again, I end up with that coefficient of plus 9x. Okay, so looking at that, that means that our factored form will have our common binomial factor of x squared plus y squared, and then our resulting binomial factor of 1 plus 9x. Our last problem on this page is the expression x times x plus y squared minus the quantity 5x plus 5y. So this time I do have parentheses, but they aren't the same. So we have to think a little bit about this before we kind of write it out in our hockey stick because we want it to be organized. So for this, I have an x plus y. I can't simplify this. But if I think about 5x plus 5y, can't I factor out a GCF of 5? So these terms here have a GCF of 5. So if I factor a 5 out, and I'm going to write this over here, there's already a minus sign there, but I'm going to divide each term by 5. Apparently a monster 5, because that's where I am on my pad. 5x divided by 5 is x, and then 5y divided by 5 is y. So this piece here turns into a negative 5, right, because the minus, GCF of 5, x plus y. If I were to distribute, I would get that back inside. So I want an x plus y. In this one, I actually have 2 of them. So we're going to expand that. So let's, because we have 2 of them, write it out twice. So we've got x times the quantity x plus y squared. So we want to think about that as x times the quantity x plus y times another quantity x plus y. The reason I want to do it that way is because then it's obvious that I can take one of these away as my common binomial factor, but one has to stay. Okay, so I'm able to take out that x plus y now that is shared with both of those terms, and now I'm left with an x and another x plus y, and then this one I'm left with just a minus 5. Okay, so I have still a binomial, but I have a product going on, so I want to put that inside brackets since there's already parentheses there. So one of my factors is x times x plus y minus 5, and then my first factor stays the same, it's x plus y. Okay, so that's factoring GCF when I have a common binomial factor.